Okay, this video introduces you to classes, which also introduces you to object-oriented programming. So we're going to start by creating a class. I'm going to call the class coffee, right? Because an object is simply something that exists in the world, or in any form. Anything is made of objects. If you think about it, a pen is made of objects. It's made of the ink, which is an object. The point is an object, the tube that it's holding, the container, right? All those things are different objects with different properties and different functionality within the other objects. So objects coming together form a bigger object. Alright, so here we're going to create a class. We're going to start with its header file because classes are defined within the header file. Right, definition normally is in there and that's it. No implementation, nothing of that nature. Alright, so I'm going to call this one, and the name of the class normally corresponds to the class name. So we're going to create coffee. So there's a coffee header file. Right. Within this coffee file, I know I'm going to use strings, so I'm going to include the string library. Alright. So to start the definition of a class is the keyword class, the name that you want. Normally they start with uppercase letters. And then the curly brackets that define the region, and you see that it also put in a semicolon at the end of it. So this set of curly brackets defines everything that's going to be part of the coffee class, right, within the curly brackets, and there must be that closing or that semicolon on the closing curly bracket there. Right. Class is made up of two parts. Excuse me. Alright, the private parts, this is data or methods that you do not want anything outside the class to access. And then the public is just that, it's the public interface, the public methods and data that you want externally to be accessed. Alright, doesn't matter which order you put them in, private at the top, public at the top, doesn't matter. Anything that follows it up to the next one would be, like in this case, everything between private and public would be private, and anything after public would be public. Alright, so normally all the data should be private. We try to do that for data hiding, protecting the data, let the class control the access. So coffee, give it a name, the type of coffee that it is. It's going to have a price to define it, the way we're using it in our program. It's going to have a weight, right, the package weight. And we're going to keep track of basically how many we have. It's kind of an inventory little program going on here. So we'll go with quantity. Alright, those are the attributes that define what a coffee is, right? It's got a name, it's got a price, it has a weight to it, and we have how many are currently in stock. Alright. Something seems to be wrong with my include here. Namespace is spelled wrong. There we go. Alright, so there we go. Fixed in. Alright, so again, this is defining an object, right, and those are its attributes. The methods that are part of the class, and they can be private methods also. Those are methods that you want to only use within the class itself. But we're only putting definitions here, or function prototypes. Alright, we want the ability to set the price. Alright, so that's going to take a double coming in. Alright, and a semicolon. Another one could be to get the price. The price is a double, so we get price. Right? These are setters and getters, or accessors and mutators as they're called also. Right? All within the object-oriented programming world. Right? So all I'm going to add are a bunch of setters and getter methods. Keep the class somewhat simple right now. So I have setters and getters for the price, the weight, the name, and the quantity. Alright, you notice on the gets, they are all have a constant at the end, except for the first one I put in. There we go. We don't need those methods to modify anything. They're get methods, so they should only be returning data. So we make it constant. It prevents it from changing data by accidentally coding it in there. This will prevent that from happening. So this is a definition of a class. A declaration of the class simply defines what it has as data, those four pieces of data, and the methods that it has, public and private methods. And again, the private section is the stuff that we don't want access outside the class to it, where the methods are the thing, or the public I should say, is the methods or the data that we want anything outside the class to have access. A class is also defining a new data type. So this new data type is coffee. So right now it's equivalent to an int, a double, and floats, and all those things. We can declare variables of it. This is a user or a programmer defined data type, right? An abstract data type, ADT, as you'll come across, right? So a class typically has a header file with that declared in it, and then it also has an implementation file or a CPP file, which goes by the same name also. Alright, so the only difference being its extension. So these are two completely different files, right, independent of each other. To connect the two files, you need an include statement to include the header file, coffee. So when you create your own header files, those go in double quotes, such as that. Does not need the using namespace std because we haven't created any namespaces within the class, right? That's a whole other topic. So now we can start creating the methods and tying them together. Alright, so let's start. Alright, I got some code here already, so let's paste that in there and explain it. So this piece, right, there's the set price, one of the methods we put in the header file. It had a parameter for a double, so you can set the price. This piece here with the coffee and the two colons connects it to the class. It says this method, set price, is part of the coffee class. Right? Everything else needs to match. It was void in the header file. It's called set price with a capital S, capital P. It had one parameter, oops, excuse me there, of P, right? If you go back, you see this is pretty much identical, except there's no semicolon, and we added the colon, coffee colon in front. It takes P in, checks that it sets the price. Right? So why does the data need to be protected in terms of making it private? Because we can add something of this nature. Right? If price or P that's coming in, let's say it's negative. Right? If it's less than 0, we really don't want to set price to that. Right? It doesn't make sense for price to be anything less than 0. Otherwise, if it's not less than 0, that's when we want to set the price. So we're in control here to say what we want to happen if something invalid comes in. In this case, we'll set it to 0. Or you could do nothing. Right? Just make an if statement as long as P is greater than or equal to 0, or greater than 0, we set P. Right? Either way, you're in control here is the concept. Right? That's why we make data private, to protect it, make sure no invalid data comes in, right? Not expecting the code external to the class to make sure that the price is greater than 0. Right? Even if you're expecting it, control it yourself here. Sometimes you output a message, right? That's okay, but in some programs, but some programs just need to run and then the output is meaningless, right? So we just want to make sure we're protecting the data here, right? So it's information hiding, data hiding, protecting data, right? All that's what's going on in there. That's why we want it to be private. It's very important to object-oriented programming. Right? This is a very simple class, so the logic in here is going to be very simple, but the concept is just that, to protect data. Alright, I have all the other ones done already, so I'm going to copy those in here. And I kept them simple. All the sets will set the data members and so forth, not checking any more data. Just wanted to point that out to you there. Alright, the constant there again will not let me change anything. Alright, something of that nature will give you a compile error. You can see right here it's already telling me it can't be modified. Alright, so you would get the warning when compile time or while you're typing, depending on the environment you're using. So this is the implementation file for the class. This is the header file or the declaration of the class. A lot of textbooks will show you a lot of the sets and gets, or what we call inline methods. That's has a whole different effect when you compile the code and what it does with it. This is meant to be something you can hand off to somebody. Say, here's my coffee class. This is the methods I provide. This is how you're going to work with me. The other person shouldn't really care about the implementation. They don't need to see what's going on behind the scenes. So as long as your class does what you advertise that it does, and the methods that you provide it does what they need to do, and as you define them to be, right? So it's kind of an interface between classes. When you design an object-oriented programming, that's what you're defining, the interface between all these objects. How are they going to communicate to each other? And that's that public interface right there. Right? They don't need to know about the data really, but it's in the header file, but their concentration is really on the public. They cannot access the private data members within there. So that's how you define a class. You tie it back again between the header file at the top, right? And then this class name : to tie the method to the class. Right? You notice I did not have to include this string library here, even though we have strings going on within here. That's because when I include this coffee.h, I'm getting the string include also. Right? So the includes include whatever is in the other files also. Right? So that's why we use this using namespace standard, so that it helps prevent it. Well, it tells it which one to use, but this propagate once up here is what prevents from being included multiple times. So if another file was to include coffee.h, it knows not to, because the compiler already knows this definition, so it can link everything as it needs. It won't try to include it again. The other method you see is the pound if defined, if not defined, and then defined, and the end if at the bottom. There's two different ways of doing it. They have the exact same result. So now we defined a new data type. Now let's just show that it does work. We're going to add now another file for our main, which we'll just keep as our source here. Alright, and just create a couple objects to make this work a little bit. Alright, so one thing I do need to include is the coffee header file. Right, so I can create coffee objects. Right. It doesn't need the namespace there. Right. Let's include the IO stream, maybe. A couple things here. Let's see what we're going to do here. Alright. Alright, so again, that using namespace doesn't need to be there for coffee. Coffee can appear after that if you want. And there's our main, and there's our return 0. Alright, so there we go. So again, coffees, it's something we declared, so now we can create data, we can use it as a data type, and we can declare variables. Alright, we can create 2 of those. Alright. Now those variable names have no effect on what the actual objects have in it. Alright, but there's 2 objects, they are created. Now we have 2 instances. This header file, no memory is allocated, right, until I do something of this nature. That's what allocates the memory for those variables in there. Alright, and creates the objects. Now we have what's called instances of the class, right, or the physical objects. So dark roast and espresso now are objects that exist, they've been created and they exist in there. Why is it complained by my espresso? ESPRESSO. Oops, I got an X up there, one S. There we go. Alright, so now I have 2 distinct objects. They're calling the methods and they are not interfering with each other. Right? They are independent objects. Right? So when I change the name for the dark roast object to Colombian, it's going to be Colombian, and when I set the espresso to French espresso, it's going to be espresso. Alright, so all I'm going to do is output them using the get. So I used all my sets up here. Here I'm using the gets. Right, I'm using set position there, so we need a few more includes there to get this to compile. What else we need there? We need the IO manip there, IO, that guy, and we need string probably also. Alright, so again, the sets, I'm setting them all at different things. Quantity that's in there, the price, the weight of them. I kept them the same there, but I could change that just so you see that they three are the fourth properties or the attributes of the two objects will be different once this runs. Alright, so again, you're creating objects, you're creating a new definition or a new data type. Right, and we're creating variables of them. So anything you do with those regular variables, integers, doubles, and floats, you pretty much can do with these objects. As we move along and make it more advanced, you'll see there's a lot more things we would have to add. I spelled string here wrong. Hope the include's wrong. Sorry about that. Alright. Alright, so again, that's what an object is, or a class. It's a definition of a new data type. The object is when you create an instance of it. We have two instances here. That's the dark roast and the espresso. And you see that on the first output, the dark roast, which should be Colombian. Alright, the weight, oops, sorry about that. Alright, the weight is the 1.2 is what we set. This, what did I do there? Let's see for the cost. Get the price times the quantity that's in there, and using the methods in multiplication there. That's all this is doing. So I have 5 in stock at a $5.99 each. Gives you that $29.95. And I did the same thing down here. So the methods can be used in expressions, assign the variables, whatever you need to do with the gets. But you see that the two are different. Right, the other one has 10 in stock at $6.99, so the total there is $69.90. Right? And that's how you create objects. Right?